We are covering 8-5 Part 1. So we're going to solve rational equations. Part 2 is about solving rational inequalities. All right, so a rational equation is an equation that contains one or more rational expressions. We did a little bit of this in 8-2. We're just going to get into a little bit more complex types of rational equations. So we want to solve the rational equation by turning it into a regular equation. In other words, getting rid of the denominator. How do we get rid of the denominator? We multiply by the least common denominator, and I want to apologize. Last time I was calling it GCD and it really should have been LCD, least common denominator. So you might want to change that in your notes from 8-3 Part 2. All right, so we're going to multiply everything by the least common denominator. If we multiply everything by the same amount, it doesn't change the equation, and it basically allows us to cancel out all of the denominators. So as it says, this step eliminates denominators and results in an equation that we know how to solve. Right, first equation. So we want to find our least common denominator, or least common multiple. We only have one denominator, and the only factor we have is x. So x is going to be our LCD. So we're going to multiply everything by x. So notice we've multiplied each term in the equation on both sides of the equation by x. And what happens here, when we multiply this by x, it cancels the x in the denominator, and now we end up with this. Well, what is this? How do we solve this? It's going to be a quadratic. And you can solve it any of the ways that you know how to solve quadratic. The easiest thing to do, I think, is going to be to move this over, factor it, and use zero product property. So this factors into x, what is it? X minus 6 and x plus 3. If you wanted to use quadratic equation, you could do that as well, but we've been factoring for quite a while, so this is probably the easiest thing to do. And then zero product property, set each of these equal to 0 and solve for x. And you're going to end up with, x is equal to 6 and -3. So that seems simple enough. The only thing is, I told you, I think when we did 8-2, that whenever you solve a rational equation, you will need to check, because you can get invalid solutions. So it doesn't tell you to check, but I'm going to write in big red letters here, check all solutions. If you stop here, you've only done half the problem, because we don't know, in fact, if these are real solutions. So that's what we're going to do next. We're going to check both of those values, plug them into the original equation. So here's our original equation. Plug x in, which is 3. Oh, sorry. We're checking out x equals 6 here, and this is x equals -3. So we plug 6 in wherever x is in our equation, here and here. And notice it says it equals 3. So if we end up with 3 on this side of the equation, then we're good. So in fact, we get 6 minus 3, which is 3. 3 does equal 3, so that's a valid solution. Here, we're going to plug in -3 for x. Minus a -18 divided by -3 is a +6. This is a -3. +6 plus -3 is 3. So this one also checks out. So our two solutions are x equal 6, -3. All right, why don't you try and solve that one? And then we will move on to the next concept, which is extraneous solutions. So it kind of goes along with the whole checking thing. If you have a solution that's derived, well, an extraneous solution is a solution of an equation derived from an original equation that's not the solution to the original equation. So when we do deal with rational expressions, we simplify, we cross things out, and in the process of solving an equation, you can simplify, cross things out, and end up with a solution that doesn't work in the original, and that's called extraneous. So that's why we always check our solutions, because it may be extraneous. So when you solve a rational equation, it's possible to get extraneous solution. These values should be eliminated from your solution set. So as I said before, always check solutions by substituting them into the original equation. Solve each equation. So this isn't really anything different than from the first example, except in the first example there were no extraneous solutions. I'm guessing these we are going to find some. All right, solve each equation. So remember, we find our LCD. The only denominator we have, the only factor we have is x minus 2. So that is our LCD. So we're going to multiply every term by our LCD. So we're going to multiply both of these. Notice that causes these to cancel out. Since we multiplied the whole equation by that expression, it doesn't change the value. We're still there. Okay, and that leaves us with just 5x equals 3x plus 4. This is a linear equation. Hopefully we know how to solve this. Subtract 3x, and you get 2x is equal to 4. Let me get rid of this. So when we subtract we get 2x equals 4, or x is equal to 2. All right, so we need to check this to make sure it's not extraneous. I will plug it into the original. So don't plug it into this, because of course it's going to work. That's where we got the solution from. Don't plug it in. Well, yeah, don't plug it into, at this point, we want to plug it into this. So when we plug x equal 2, and you can already see what's going to happen, 2 minus 2 equals 3 times 2 plus 4 over 2 minus 2. These become 0, and we get 10 over 0 is equal to 10 over 0. Undefined is equal to undefined. We can't have an undefined solution. So it's extraneous, meaning this equation has no solution. Next one. All right, so we want to find the LCD. We've got two different factors for our denominators, x minus 8 and 2. That's going to be our LCD. So we're going to multiply top and bottom by 2 times, I mean not top and bottom, we're going to multiply everything by 2 times x minus 2. Both sides 2 times, x minus 8. So when we multiply both sides by 2 times x minus 8, on this side, the x minus 8 is going to cancel out. On this side, whoops, I forgot about this one, x minus 8, 8 times 2. Here the 2's are going to cancel out, and here again the x minus 8 is going to cancel out. So you are left with, hopefully they show you what you're left with. So here I'm left with two times the 2 times 2x minus 5. Here I have the x times x minus 8, and here I have my 11 times 2. So distribute and simplify. This becomes 4x minus 10. This becomes x squared minus 8x, and this becomes 22. This is a quadratic, so we're probably going to move everything over to one side and factor to solve. So combine my like terms here, subtract my 22, and that's going to give me x squared minus 4x minus 32 equals 0. So x minus 8, this factors into x minus 8, x plus 4 equals 0. Set both of those equal to 0 and solve, and you're going to get these two possible solutions. And now we're going to check by plugging it into the original. So let me get rid of all of this. If I have x equals 8, I'm going to end up with, well, you can see when x is equal to 8, that makes those denominators zeros. So x equal 8 is not valid. It's extraneous. What about x equals negative 4? We're going to get 2 2 2 times negative 4 minus 5 over negative 4 minus 8 plus negative 4 over 2 is equal to 11 over negative 4 minus 8. So what is that? Let me go down here a little bit. You end up with negative 8 minus 5, negative 13 over negative 12. Negative 4 divided by 2 is going to be minus 2 is equal to 11 over negative 12. So what's negative 2? If I multiply top and bottom by 12, I'm going to get negative 13 over negative 12, which is a positive actually. So this turns into a positive 13/12 minus 24/12 is equal to, and this is a negative 11/12. 24 minus 13 is 11. So we end up with a negative 11/12 is equal to negative 11/12. So this one is valid. So our solution then is x equal negative 4. That's the only valid solution. It's a lot of work. I know, I understand that. All right, this is one for you to solve. Remember, please check your solutions and bring any questions to class. I know we're getting very complicated here. So this is your homework. See you next time.